Hello friends, welcome to today's session on decision tree concept. If you have watched my previous videos on linear regression and logistic regression, you have probably noticed that we used mean square error in linear regression, sigmoid curve in logistic regression. But here we are going to explore a different technique, the technique of splitting the data to arrive at a decision. We are going to cover data analysis, how to split data, tree-based algorithm, chart, entropy, and finally do small hands-on exercise. We'll start with data analysis first. Here we see a small data set of patients admitted to hospital with specific diagnosis. Dataset has features like age, gender, admission diagnosis, length of hospital stay, insurance type. The result of the target shows some patients are readmitted within 30 days of discharge. To develop a model, we'll tweak the data slightly. We'll group the age like 40 to 49, 50 to 59, and so on. And we'll group the length of hospital stay like 1 to 5, 6 to 8, and so on. After adding the two columns, the dataset looks like this. The model is developed with this dataset. Now comes the problem statement. If a new patient is about to be discharged, what is the probability that the patient might be readmitted within 30 days for the same complaint? Now suppose I work in a hospital IT department, and IT department has already developed a model with the basis of past data of the patients. Now a patient is about to be released, and the management team sends a request to IT department to analyze the data of the patient and give them a figure showing the chances of readmission within 30 days. It's just analysis, not any medical assessment. Now, what question will I ask? These are the parameters, like age or age group, the gender, the admission diagnosis, length of hospital stay, insurance type. These are the parameters. Now, the question that I will ask, what is the age of the patient? What is the admission diagnosis? What is the length of stay, and so on? So each question is actually intended to split the data set. And when I ask the age, I restrict my analysis within that particular age group. That is the first split. If my next question is, what is the gender? Then I further narrow down the data set for analysis. I'll go on asking the question and traverse the model till I find unambiguous answer about the chance of readmission. So in this process of splitting, what would be the best method of splitting? Let us analyze 4 scenarios. There could be numerous other scenarios also based on number of parameters. In scenario 1, we find that the first level of splitting is done on the basis of gender. And the second is on the basis of diagnosis, admission diagnosis. That's the scenario 1. So there could be other scenarios like split on admission diagnosis first and then split on the age group. And the third scenario, split on the insurance type first and then split on the admission diagnosis. In the fourth scenario, they split on the length of hospital stay and the split on the age group. So at this stage, we don't know what is the best criteria. So what would be the best criteria for splitting the data? The criteria that can arrive at a conclusive decision with minimum number of splits. That essentially means the more the unmixed data at leaf node with minimum level of splits, the more efficient it is. And the prediction will also be a better one. Now let us understand the common terminology about the leaf node and decision node. If we denote the data set to be at the root node, each split generates sub-branches just like a tree, an upside down tree. You remember the first picture? If a node can be split further, so this is the root node, and the first splitting is done, and the 2 decision nodes are there. So if a node can be split further, it is a decision node. If a node cannot be split any further, it's a terminal node, like this one, this one, this one. So the terminal nodes. So for the best split, we need to use a few tree-based algorithms. We had seen earlier that there could be many ways to split the dataset. Definitely, we cannot do trial and error, so we'll have to use some algorithm that will tell us the best way to split the dataset. Two algorithms are quite popular. One is CART, the classification and regression tree, and other one is the ID3, this iterative dichotomizer tree. In both these methods, the objective is to arrive at a terminal node that guides to more homogeneous or pure results. In CART, we use Gini impurity, and in ID3, we use entropy calculation. We'll see the calculation methods of Gini and entropy. To calculate the Gini impurity, we have to calculate Gini index first. Gini index calculation is the sum of squares of probabilities of each parameter being positive or negative result. So here, how many females are readmitted? 3 readmitted out of total 14 females. So the Gini index for female is 3 by 14 whole square plus 11 by 14 whole square equal to 0.66. So similarly for male, it is 5 by 16 whole square plus 11 by 16 whole square equal to 0.5703. So in this example, we split on gender, then we calculate the probability of females being yes and no, and then get the sum of squares of those probabilities. Then we calculate the probability of males being yes and no, and then get the sum of squares of those probabilities. Once we get the Gini index, we can get the Gini impurity by deducting Gini index from 1. Then we get the weighted average of Gini impurity on gender. So we need to calculate the Gini impurities for all the other parameters. Here we see the Gini impurity calculation if the split is on the basis of age group. You can pause the video over here and see the calculation details. After we calculate the weighted Gini impurities for each of the parameters, we need to select the lowest one, which indicates the best split at this level. So in this example, we find the split is on the basis of length of hospital stay, and that is the best split at the root level. In this example, we find split on the basis of length of hospital stay is the best split at root level. At the next level, we'll have to again do the calculation for the rest of the parameters, and we'll need to continue to split until we find that no further splitting is possible or necessary. Now we'll see the other algorithm. In ID3, iterative dichotomizer 3, we use the calculation method known as entropy and information gain. Entropy is the randomness of information. Here we see 3 scenarios, A, B, and C. In the first picture, blue and red dots are equal in number. Hence, there is equal probability of picking up any color. In the second picture, blue colors are more in number, and hence there are more chances of picking the blue one. That means less randomness. In the third picture, it shows that all the dots are in blue color. So that means there is no randomness. So entropy calculation details are shown below. Entropy for each section is the summation of negative probability multiplied by log base 2 of that probability. Well, so we have calculated the entropy. What next? As I said, entropy is the measure of randomness. Hence, it's not a good split if the entropy is high. So we use the measure of information gain, which is 1 minus entropy. In the picture between blue and red dots, when both are equal in number, the probability is 0.5. So in this case, we find that the probability is 0.5. So that means the entropy is at the highest level, that is 1. And on the other hand, when probability is either 0 or 1, that means either fully red or fully blue, entropy is 0. And in that case, information gain is 1. With the entropy formula, entropy of current dataset is 0.84 here, which is almost near 1, which means the state is not pure. Hence, we need to calculate the entropy for the next level split on the basis of either gender or admission diagnosis or length of stay or the insurance type. Here you see the entropy calculation on the basis of split and gender. You can pause the video here and see the detailed calculation. It's almost self-explanatory. During classes, we actually follow an Excel template to calculate Gini impurity and entropy. You can also try to create the Excel for the detailed calculations. When we complete weighted entropy calculation on the features, we find that entropy calculation on the length of hospital stay is the minimum here. And hence, information gain will be maximum if the split at the root level is done on the basis of LOHS, the length of hospital stay. Now we do a hands-on exercise using Python, Pandas, and Scikit-Learn. One interesting point over here, whatever calculation method we discussed here are already embedded in Scikit-Learn. We don't need to write any program for Gini calculation or entropy calculation. Gini and entropy selection is just one parameter selection. But I took all the time to explain the internals so that when you select Gini or entropy, you know what is happening inside. One more point. In Scikit-Learn, when we build the model, it is always a binary split. Algorithm selects the most efficient binary split. We'll see the tree plot in the exercise. So here is the tree plot that is generated out of the model that we have built. So we have learned the concept of decision tree and how to split the data, classification and regression tree, and entropy calculation, Gini impurity calculation over here. We have also done a small exercise on that. So for today, thank you.